the metal particulates, all of those can be used and leveraged to create weather events that are several standard deviations or outside what would be typically normal. When the geoengineering really got underway with the Russians in the mid-70s, we ended up with snow in Miami. We ended up with frost deep into Mexico. The bizarreness of the weather really exploded on the scene when weather engineering got going in the mid-70s.
The Dakotas, in winter, they recorded a temperature of almost 100 degrees, 94 degrees. It broke the former record by 32 degrees. There's very profound things that people don't notice. Blue skies almost never. We almost never have dew on the ground. That's a known consequence of geoengineering, if they did it, which they appear to be. It sucks the moisture out of the atmosphere, it doesn't descend, doesn't form dew. We have massive temperature disruptions. People are starting to wonder, why is it 80 degrees one day and then snowing the next day at 50 degrees or 45 degrees and then back up to 80 the day after that? When you push and pull the climate with these manipulation programs, of which there's a mountain of data to corroborate their existence, then you start to have massive fluctuations in the system. And we saw in March in the continental U.S. there were 15,232 temperature records broken. That's profound. Some of the daytime highs, the former records were broken by as much as 32 degrees. Don't people wonder what in the world is going on?
Whether they want to make it snow at 45, 46, 47 degrees. I remember when 38, 39 was a big deal. Those kind of snowfalls in the upper 30s. And now that's been pushed into the 40s.
There's a patent called ice nucleation for weather modification. This is a patent from NASA. It can be found online in its full form. This patent is for the creation of artificial snowstorms from what would have been rainstorms. However preposterous this sounds to people, if they look up Chinese create snowstorms, they will find a long list of articles where the Chinese Bureau of Weather Modification openly admitted that they were creating snowstorms until they did $1 billion worth of damage in Beijing. So my question would be, if the Chinese can do this, and NASA has a patent for the same purpose, why would we believe snow events here are natural when it's snowing now regularly at 45 degrees, sometimes 50 degrees, heavy, wet, concrete snow that's full of aluminum, full of barium, full of strontium? Consider the ice pack in their first aid kit that can sit dormant at room temperature for decades until the chemicals are mixed together, at which time it creates ice.
As an on-air meteorologist, I had a responsibility to my audience. There were storms that were not behaving as they were modeled or they historically would have responded.
If you can control where moisture is collected and where it's dropped, so to speak, in the form of rain or any other kind of precipitation, then you can really, you can do everything. You can steer the weather system. If you want to be able to manipulate the weather, one of the things we know about the materials that are being used in the aerosols, we've seen everything from aluminum oxide, barium salts, strontium, copper sulfate, potassium iodide, a number of different kinds of things, each of which have different levels of reactivity with the moisture in the air. Some, like aluminum oxide, tends to sequester the moisture. The aluminum oxide nanoparticles, which are microscopically fine and uniform in size, attract the humidity, the moisture in the air, and it basically forms like a nucleation process where the moisture condenses on these particles.
With cloud seeding, the cooling will be achieved by making clouds reflect a bit more sunlight back to space than they would otherwise, and less sunlight reaching the surface would tend to cool the planet. These aerosol particles act as something called cloud condensation nuclei, and these are sites where these particles act as sites where cloud drops can form.
Well, the one thing that we know has happened is because these are nanoparticles and they float like mad with a little bit of moisture added to them, they go over the Continental Divide, they dump all of California's rain into the Mississippi Valley, which is the reason they're having floods and tornadoes and fierce storms and odd weather back east. The effect here in California is drought.
Now then, if you hit that area of the sky with a beam of a particular kind of radiation, and you can heat those particles up, just like heating up, your cup of coffee in the microwave. These particles begin to vibrate and resonate, if you use the right frequency of RF energy, that they then heat the surrounding air, and they will take all of that air and the moisture that is in it to a higher altitude where it's much colder, and it'll condense and then become a low pressure system.
Well, there's a couple of locations where they tend to be very interested in leaving their trails. The big one and the surprising one for me is under areas of high pressure, where you would expect to see the blue skies, the dry conditions. Those are prime targets for trailing. A couple of reasons. High pressure is stable. It's relatively still. You know, we've got the clockwise flow around it, and if you accentuate the high, so it's very easy to add those particulates of aluminum, barium, and whatever else they want to put in there, and as you add heat to that, those particulates then radiate the heat into the atmosphere, and it warms. And what does a warming atmosphere do? Boom, it expands. So that's one way. It's a very simple way, but it's very apparent, because under the high pressure, it's supposed to be quiet, it's supposed to be still, it's supposed to be blue, and we're not seeing that. Then as the storm approaches, the high begins to recede, and then they're running the flights back and forth, back and forth, back and forth, and literally seeding the leading edges of the cirrus. So the cirrus canopy is accentuated. That cirrus canopy, which would maybe be 200-300 miles out ahead of a cold front, is now 450 miles.
Based on geoengineering data, it would appear the Pacific Northwest gets an excessive amount of the fallout from these programs, because much of the weather, much of the precipitation and the storm tracks and the jet stream move across us. So, as stated by globally recognized geoengineers like David Keith, that's the type of area they would want to seed these particulates as incoming fronts start to cover landfall. And that's exactly what we see here. When there's any kind of incoming front, we see jets everywhere.
The global studies indicate there will be some impact on precipitation patterns, and obviously there's a lot more opportunity for work in that area.
After studying my time-lapse surveillance, one of the reasons I discovered for the trails was that the persistent ones would break, they would misshape it or deform, and other planes would come along and precisely mark off those locations of deformation. And you're not going to get that with a regular fleet, so this had to be one of the primary purposes for chemtrails, in my opinion, was to measure off where we have these discontinuities showing up in the atmosphere. And in doing these actions and discovering those zones where there's different energies in the atmosphere, I think that plays very closely into their weather engineering programs of mark, surveil, and then that data goes into a weather model that they can then use to forecast or, once again, engineer the weather to their designs.
But you can also influence what happens locally with the atmosphere by painting the materials that those aerosols are made of with different kinds of radio frequency or RF energy, radar, microwave, the HARP system.
You know, HARP is an array, a field of antennas, radio frequency antennas. They're 72 feet tall, and they have a cross dipole across the top that's about 60 feet in each direction. 180 of these are in the array today, so you can imagine this field of antennas. What happens is by firing each one, they produce radio frequency energy that normally comes off of an antenna, spreads out rather rapidly. Same principle.